This 8-minute video goes through the rules of indices and then gives 3 examples of Leaving Cert higher level questions in this area. The rules of indices are given in the log tables, but here's a reminder of the basic rules. We have an addition rule when we're multiplying, say, powers like 6 cubed multiplied by 6 to the power of 4. We add the powers and get 6 to the power of 7. There's a subtraction rule for division. So 4 to the power of 5 divided by 4 to the power of 2 gives me 4 to the power of 3. There's a multiplication rule when we see brackets. So 2 to the power of 4, all to the power of 3. We multiply and get 2 to the power of 12. Anything to the power of 0 is 1. And this is worth remembering. Something to the power of minus 1 can be rewritten as 1 over that written as a positive power. So 3 to the minus 1 is equal to 1/3, 1 over 3. When we deal with fractional powers, and we're talking about roots, so 7 to the power of a half is the square root. Here we might deal with more complicated fractions. The number on top is a multiplier, and the number on bottom is a fractional or root number. And here, when we have a power outside in brackets, it applies to both terms if both terms are multiplied. So 2 multiplied by 5 to be squared is 2 squared multiplied by 5 squared. And there's the rules of indices. Now let's look at a couple of examples in this area. Okay, in example 1, we're to evaluate each of the following. In the first question, we have 27 to the power of 1/3. So anything to the power of 1/3 is the same thing as the cubed root of 27. So what number multiplied by itself 3 times gives us 27? And the answer is 3. This is because 3 cubed is 27. So 3 is the answer to the first question. Question 2. It's 36 to the power of 3 over 2. The over 2 bit means the square root of 36, and this is going to be cubed. And the square root of 36 is 6, because 6 sixes are 36. So it's 6 cubed. And 6 cubed is 216. You could use a calculator on that part if you need it. Part 3, we have 64 to the power of minus 2 over 3. Well, firstly, dealing with the minus bit, we can write this as 1 over the cubed root of 64, all to be squared. Now, if we think about the cubed root of 64, we know that 4 cubed is 64. So the cubed root of 64 is 4. So it's 1 over 4 to be squared. And 4 squared is 16. So the answer is 1 over 16. Okay, and the last question, part 4. In this we have 27 over 125, all to the power of minus 2 over 3. Now to deal with the minus part here, we could just invert the fraction and write it as 125 over 27, and this is all to the power of 2 over 3. Now the 3-bit means we get the cubed root of each of the parts. So the cubed root of 125 divided by the cubed root of 27. And all this is going to be squared in a minute. So what's the cubed root of 125? Well, you might know that 5 to the power of 3 is 125. And we here already have that 3 cubed is 27. So the cubed root of 125 is 5 and the cubed root of 27 is 3. And this is all to be squared. So we square 5, we get 25, and square 3, we get 9. That's the answer. In example 2, to simplify each of the following using the rules of indices. Okay, let's look at the first question. Now it looks complicated, but if you use the rules of indices, the dividing powers or dividing terms are subtracted. So we have x squared, and underneath we subtract minus 4, so that's minus minus 4, and we have y to the minus 3 on top, and we're going to subtract 5 because that's underneath, and everything is the power of a half. So 2 minus minus 4 is 2 plus 4, which is 6, and y minus 3 minus 5 is minus 8. And all this is the power of a half. So you multiply these powers by half, and we get x cubed minus y to the minus 4. Now we could write, since it's minus 4, we could write this y underneath the line as y to the power of 4. And that's maybe the neatest way of writing the answer. Okay, in part 2, if we rewrite maybe these using powers, it might make it look a little bit neater. So what we have at the moment is we have the square root of a cubed divided by the fourth root of a and the cubed root of a squared. So if we rewrite this in terms of powers, it gives us a to the power of 3 over 2 divided by a to the power of a quarter multiplied by a to the power of 2 over 3. Now the rule is if we try to neaten up what's underneath the line, we could add a quarter and 2/3. And a quarter and 2/3, if we use get a common denominator of 12, we end up with 3 plus 8 over 12, or 11 over 12. So we could rewrite the bottom as a to the power of 11 over 12 because we add the powers. Now we can use the subtraction rule here because we're dividing. So if we could subtract 11 over 12 from 3 over 2, and you could use a calculator to help you with this bit, but with a common denominator of 12, this is equal to 18 minus 11 over 12, or 7 over 12. So the answer to the question is it's a to the power of 7 over 12, and that's the answer. Okay, example 3, we're to show that the left-hand side is equal to 25 over 26. And just to clarify at the start, this 4.5 to the power of n, this means 4 multiplied by 5 to the power of n. Now the technique we use to simplify this is we factorize. You might notice that 5 to the power of n is a factor of both terms on the top. So 5n plus 1 is 5 to the power of n multiplied by 5. And minus 4 times 5 to the power of n is 5 to the n by minus 4. Likewise, in the bottom, 5 to the power of n is a factor. 5 to the power of n minus 2 is 5 to the n multiplied by 5 to the minus 2. And we have 5 to the n is just 5 to the n multiplied by 1. So we've factorized. And we might notice here that we have 5 to the n above and below the line, so they cancel out, they divide in, give us 1. And 5 minus 4 is 1. 5 to minus 2 plus 1, the minus would be 1 over 5 squared plus 1. And 5 squared is 25, so it's 1 over 25 plus 1. Now 1 is 25 25s, and if you add 1 25 to 25 25s, you get 26 25s. And we have 1 over this. Now the 1 over means you can invert the fraction, which gives us 25 over 26, which is the answer we were looking for.